Remember, we want to work with measurement in as realistic of situation as we possibly can. And what we're going to do in the next part of the lesson is to look at a real world problem that we face mainly in the summertime when we have extreme heat and we leave children in the car unattended. It's a very dangerous situation that can occur when a child is left in the car. It is more dangerous for a baby than for a child or an adult. And there are some reasons why that is. And so that's going to be what we're going to talk about today. And in doing that, we're going to be looking at surface area and volume. Now, in our model, I have one cube that will represent the baby. I have the 2 by 2 by 2 cube that will represent the child. And I have the 3 by 3 by 3 that will represent an adult. We're going to say that each of these is 1 inch long. So the baby is 1 inch by 1 inch by 1 inch. The child 2 inches by 2 inches by 2 inches. And the adult 3 inches by 3 inches by 3 inches. When we use the term surface area, we simply mean the area of all sides. So if I look for the surface area of each, I know that each is a square, and the surface area would be side squared, or length times width. And then I also know that a cube has 6 sides. So the surface area of the baby would be 1 times 1. And there are 6 sides that have that same dimension. So the surface area of the baby would be 6 inches squared. Alright, now I want to find the surface area of the child and the surface area of the adult. And I'm going to leave those for you to do. But I want you to remember that the child is 2 by 2 and the adult is 3 by 3. Then I want you to find the volume. And remember that volume is length times width times height. So for the baby, the volume would be 1 by 1 by 1, or 1 inch cubed. And then I want you to find the volume for the adult and the child. The next thing that I will have you do is find the ratio. And remember, ratio is a comparison of two numbers. It can be written as a fraction, can be written using the word 2, or it can be written with a colon. And I want you to find the ratio of the surface area to the volume for the baby, the child, and the adult. So the surface area of the baby will be 6 to its volume of 1. Now, in a ratio, we do not use units, so I would not have inches squared and inches cubed in that writing of the ratio. It'll just be 6 to 1. So if I look at surface area as being the skin that covers the body, and I look at the volume as being the interior, or the amount of fluids that are within the child, I can see that a 6 to 1 ratio is pretty great. The ratio of skin to interior is 6 times greater. So since the skin is the organ of the body that regulates heat, I want you to come, heating and cooling, I want you to come to a conjecture about why it is so much more dangerous for a baby to be left in the car than for a child or an adult, based on the numbers that you get from this example. Next, I want you to calculate your surface area and your volume. And I'm going to do an example that you can go by in order to get your answers. We say that if we take our height and we square it, and then take 3/5 of it, then we will be able to calculate an approximation of our surface area or our skin. Now, there are other ways of doing that. One way is to put your hand on grid paper and trace it and count the number of blocks and multiply that by 100. One way is to measure the circumference of your thigh. And so you would take twice your height times the circumference of your thigh. But we're going to use the one that says 3/5 times your height squared. And that's going to be an approximation for your surface area. Now, most of us know our height in English units, inches. But we want to change our units to the metric system, because when we compare our volume shortly, we can do so more accurately using metric measure. So I know that 1 inch is approximately 2 54/100 centimeters. So I'm going to use a measure. I'm 5'3", and I think probably there will be others in our class that are that height. So I'm going to say that I am 4 foot 3 inches tall. So the first thing I will do is change all of my units to inches. So 12 times 4 would be 48 inches plus 3. So I would be 51 inches tall. So how many centimeters would that be? So I can set up a proportion. 1 inch is to 2 54/100 centimeters, as 51 inches is to how many centimeters? So I do product of the extremes is equal to the product of the means. So this person would be 129 54/100 centimeters tall. So to estimate our surface area, I would take 3/5 times 129 54/100 squared. And then multiply that by 3/4 or 3/5. 3/5 is 6/10. So the surface area of this person is approximately 10,068 4/10 rounded centimeters squared. So that's how many square centimeters there would be on the body. So that's about how much skin that person would have. So you take your height and change it to centimeters, and then use the formula to estimate your surface area. Now we're going to estimate your volume. So let's say that you weigh 80 pounds. We want to change our weight to milliliters. Because in the metric system, 1 milliliter of water is 1 cubic centimeter of water, and that weighs about 1 gram. So if we can get a milliliter compared to a cubic centimeter, then we will have the same relationship. So I'm going to take the weight of 80 pounds and I'm going to divide it by 2 2/10. So 80 pounds divided by 2 2/10. So that's approximately 36 4/10. Then I'm going to multiply that by 900. So that's how many milliliters the person is. So if you compare surface area to volume, is that going to be similar to what we got for the child in our contrived situation? So we were looking at measures that 4 foot 3 inches would be like a child and 80 pounds would be like a child. So these measures would be similar to the child's measures. And now yours will be compared to the adult. So you will want to look at, are the measures that you got similar to the one that we got from our blocks when we used our blocks. So once again, to get the surface area for yourself, you're going to change your height to inches. Then you are going to set up a proportion and multiply your height in inches by 2 54/100. You will take that height, which is your height in centimeters, square it, and multiply it by 3/5. Then to get your volume, you're going to take your weight in pounds, divide it by 2 2/10, multiply it by 900, and that will be your volume in milliliters. The reason we are doing 2 2/10 is there are 2 2/10 pounds in 1 kilogram. That is the equivalence. 1 kilogram of body mass is about 9/10 liters in volume. And 9/10 liters is 900 milliliters. So that's where the numbers are coming from that I'm using. Dividing by 2 2/10 because that's how many pounds in a kilogram. Multiplying by 900 because that's how many milliliters in a kilogram. And that gives me my volume. So I have surface area compared to volume to see if it's related to what we did before. Now, why would this be important? This discussion could lead to other areas of or other subjects like reptiles. Why do they need sun to get them going? It might lead to the need for marathon runners to hydrate themselves regularly. It might give you a topic of why marathon runners are relatively small in stature. You might talk about, would there be a more realistic model of comparing a baby to a child to an adult? So as you look at the measures that you come up with in your work, like if you would do this in your classroom, or if we would bring all of our work together in our classroom to see what the ratio actually is for adults to children to babies. Maybe this might become a little bit more accurate by changing the dimensions. So these are all questions that you could have as an extension to this lesson. Now, I'm going to ask that you send to me the completed table showing the surface area and volume of the baby, child, and adult, and the ratio. I also want you to find your own surface area and volume and send that to me. I want you to make a conjecture about how accurate the cubes are compared to the numbers you got comparing your own surface area and volume.